Assalamualaikum and good day. Today we are going to continue with lecture 2 of chapter 9, which is going to focus on extreme problems. So at the end of this lesson, students should be able to find the stationary points and then classify the type of the turning point by using first derivative test. And then to find the local maximum and minimum point using the second derivative test. So we have 3 learning outcomes for today. So let's say this is our curve y equal to fx. So what is stationary points? So stationary points is actually where we have the maximum and minimum point. From the gradient, while moving through A, the gradient changed from positive to negative. So it's going up, we have a positive gradient, but at A, we change the gradient into negative gradient. So A is a maximum point. And then for B, while moving through B, the gradient changed from negative to positive. Negative gradient to positive gradient. So B is a minimum point. A and B are called stationary points or turning points. So we have two names for this, which is stationary or turning points. At stationary point, the tangent is always horizontal. Okay, so the gradient will be 0. Horizontal line is the tangent line, where the gradient here is 0. The gradient here is 0. So we know from the first subtopic of this chapter, we know to find the gradient, we need to find dy dx. And then if it's a stationary or turning point, the gradient will be 0, means that dy dx is equal to 0. And then from here we can find what is x and y coordinate for A and B. It can be 1 or 2 or more than 2 points in a certain curve. So let's see some example. So here find the stationary point on the curve y equal to 2x cubed minus 6x plus 1. So to find the gradient, first of all, we need to find the dy dx. So dy dx is equal to, so we differentiate both sides. On the right side, we will get 6x squared minus 6. So if we want to find the value, the points that will have the gradient equal to 0, means that we have to let dy dx equal to 0. So 6x squared minus 6 equal to 0, we will have 6x minus 6x squared minus 1 equal to 0. So this x squared minus 1 can be factorized into x minus 1, x plus 1. So the x coordinate here we get is x equal to 1 and x equal to negative 1. Okay, now we know the x coordinate. Can we find out what is the y coordinate? Yes, by letting the x into the equation of the curve. So we substitute x equal to 1 into the equation of the curve, which is y equal to 2 multiplied by 1 cubed minus 6 of 1 plus 1. And then we get the y coordinate, which is equal to negative 3. So the first point is 1, negative 3. And then when x equal to negative 1, we will have y equal to 2 of negative 1 to the power of 3 minus 6 of negative 1 plus 1. So what we have here, y is equal to 5. So we have a point of negative 1, 5. So the stationary points we know from the curve is equal to 1, negative 3 and negative 1, 5. So these two are the stationary points by letting dy dx equal to 0. Example 2. find the stationary point of the curve 3x squared plus y squared minus 6x plus 4y plus 6 equal to 0. So as usual, we need to find the dy dx before letting it equal to 0. So what is the dy dx? So this is implicit equation. We need to apply implicit differentiation. So differentiate both sides. What do we have? We will have 6x plus 2y dy dx minus 6 plus 4 dy dx equal to 0. Okay, now group the dy dx together. We have 2y plus 4 of dy dx equal to 6 minus 6x. So dy dx equal to 6 minus 6x divided by 2y plus 4. So if dy dx equal to 0, after we factorize out this, we will get dy dx equal to 3 of 1 minus x over y plus 2. So dy dx equal to 0. We have 3 of 1 minus x divided by y plus 2 equal to 0. We will have 1 minus x equal to 0. So x is equal to 1. So when x equal to 1, what is y? We can substitute the value of x equal to 1 into the equation here. So we have 3 of 1 squared plus y squared minus 6 of 1 plus 4y plus 6 equal to 0. So y squared plus 4y plus 3 equal to 0. So this is a quadratic. To find the value of y, we have to apply factorization. So we have y plus 3 multiplied by y plus 1 equal to 0, means that y equal to negative 3 and y equal to negative 1. So we have 2 points, which is the same x will give the same, will give 2 y's. So the point will be 1 negative 3 and 1 negative 1. Okay, now let's continue with the next part of this lecture, which is to determine the maximum and minimum point. The first method that we can use actually by using the first derivative test. So what we need to do to evaluate the dy dx on both sides of the stationary point. So usually we use table to evaluate the dy dx. So if dy is negative on the left of the point and positive on the right of the point. So negative on the left, positive on the right, then it is a minimum point. So the gradient going down and then going up after the point. So this is our point. So it will be a minimum point. Okay. So this is how the curve will look like, because the gradient is going down and then after the point will be going up. So it's a minimum point. If dy dx is positive on the left side and negative on the right, so it will be opposite from the previous one, then it is a maximum point. So because we have a positive gradient and then we meet the point and then the gradient will be negative, so it's a maximum. So let's see some example. Find the stationary point of y equal to x squared minus 4x plus 5 and determine whether it is a maximum or minimum point by using the first derivative test. So the keyword here, to find the stationary point. So that is the first task, and then determine whether it's maximum or minimum. So we need to find the nature of the stationary point, and then the method that we need to use is first derivative test. So we only can use first derivative test required by the questions. So y equal to x squared minus 4x plus 5. The first step we need to do, as usual, to find the stationary point, we need to find the dy dx. So differentiate y respect to x. What we have is 2x minus 4. And then to find the point, we can let the dy dx equal to 0, means that 2x minus 4 equal to 0. So x equal to 2. So we have the x coordinate. Now we need to check the nature of this point. Okay, so because x is equal to 2, means that this x will separate into two regions, which is this region when x is less than 2, the other side is when x is more than 2. We need to find what is the dy dx for this area and this area. We have two areas now. Okay, and then what is the point? Because we need to find the point, we need to find the y coordinate. So substitute the x equal to 2 into the equation of y. We have 2 squared minus 4 of 2 plus 5, which is equal to 1. Now we have the stationary point. And then the next part is to find the nature, whether it's maximum or minimum. So because we want to determine by using the first derivative, we need to have separate part. So before 2, we can take any value before 2. Let's say we take 1 or 0. Okay, left side of 2 will be 0 or 1. We can take any value before 2 and then the right side will be 3. Let's say we take 3. Now what we need to do is to substitute this value of x into the dy dx we found to check the gradient. So when x equal to 0, what is the gradient? So when x equal to 0, the gradient is equal to negative 4, means that it's a negative value. So when 2, it's 0, but when it's 3, it will be positive. 2 of 3, 6 minus 4 is 2, so positive. So the slope negative is going down, and then 0 will be static, and then static. We should static like this, horizontal line, and then positive is going up. Means that what is 2? This 2 is actually a minimum point. So that's why 2, 1, the point is a minimum point. So this is our conclusion after checking by using the first derivative test. So it's easier to find out the nature, the type of the stationary point by using the table form. Now, example 4. Find the stationary point of y equal to x cubed minus 6x squared plus 10 and determine the nature of the point. Okay, so we want to find the stationary and then to determine the nature of the point by using the first derivative test. Again, by using the first derivative test. So the first task here is to find the stationary point. The second, to check whether it's maximum or minimum. Okay, now let's start with the finding the stationary point. We need to find dy dx first. So differentiate both sides, we get 3x squared minus 12x. And then we equate the 3x squared minus 12x, the dy dx equal to 0. We will get, factorize out 3x, we get x minus 4 inside the bracket. So x can be 3x equal to 0. So one of it is 3x equal to 0. Another one is x minus 4. So we have x equal to 0 and x equal to 4. Okay, so we have 2 points for the stationary points. And then what we need to do, because we want to find the stationary point, we need to find the y coordinate too. So when x equal to 0, y equal to 10. And when x equal to 4, y equal to negative 22. You substitute the value into the function y equal to x cubed minus 6x squared plus 10. So we have 2 points, which is 0, 10 and 4, negative 22. So this is the first task we found out already. Now the second task is to check the nature of these 2 points. So because we have 2 value of x, we will have 5 area. So we need to find before 0, after 0, and before 4, after 4. So in between 0 and 4 will be together lah. So we can take any value before 0. Let's say we take negative 1. And then in between 0 and 4 we can take 1. And then after 4 we can take 5. So now we just have to check the dy dx of each of the value x. So substitute the value of negative 1 into the dy dx here. What we have is 3 of 1 minus negative 12. So plus 12. So will be positive. So at 0 will be 0. At 1 will be negative. And at 4 will be 0. And at 5 will be, so substitute 5 into this function, dy dx, we get 25 of 3 is 75 minus 60 is 15. So it will be positive. with positive, right? So we have going up, horizontal, going down, horizontal, and going up. Okay, now we can say that at 0 it will be a maximum point, and at 4 it will be a minimum point. So we can conclude that 0, 10 is a maximum point, and for negative 22 is a minimum point. So please write down the conclusion here. So we find out already the nature of these two stationary points. Okay, method 2. So we have another method to check the nature of the stationary points. The second method is that you have to evaluate the second derivative at the stationary point. So let's say if we get the d2y dx squared, the second derivative, and then we substitute the value of x and y, we get more than 0, then it is a local minimum point. But if we have d2y dx squared, the second derivative, when we substitute the value x and y, we get less than 0, which is negative value. We get local maximum point. Okay, but if we have d2y dx squared equal to 0, so we may say that the test is failed already. Okay, note that the first derivative must be used whenever f double prime is equal to 0 or f double prime does not exist. So here, if the test failed, what you need to do, we need to check by using the first derivative test. So example 5. Given that y equal to negative x cubed plus 9x squared minus 15x plus 11. Find the maximum and minimum points by using the second derivative test. So directly they ask you to find the stationary points, which is the minimum and maximum, by using the second derivative test. So to find the maximum and minimum, what we need to do is to find the dy dx first. So dy dx is equal to negative 3x squared plus 18x minus 15. And then we equate to 0. What we have is, now we can factorize out negative 3. So we have x squared minus 6x plus 5 in the bracket. So this constant we can just ignore. And now x squared minus 6x plus 5, we can factorize it into x minus 5, x minus 1. So we have x equal to 5 and x equal to 1. So when x equal to 5, x equal to 1, we need to find the value of y. Where when x equal to 5, we get y equal to 36. So I don't have to show this one. Just substitute the value into the function y. And then when x equal to 1, y equal to 4. So we have 2 points, which is 1, 4 and 5, 36. But now we still don't know what is the nature. So what we need to do is to check. So because the question asks you to check by using the second derivative test, so we need to find d2y dx squared. So determine the d2y dx squared. What we have to do is to differentiate the dy dx. So differentiate the dy dx, we get negative 6x plus 18. And then what we need to do for x equal to 5, we need to check for x equal to 1 and for x equal to 5. So when x equal to 1, substitute the value 1 into the d2y dx squared. We get negative 6 of 1 plus 18, which is equal to 12, which is a positive. It's more than 0, means that when x equal to 1, it's a local minimum point. So 1, 4 is a minimum point. And then when x equal to 5, the d2y dx squared is equal to negative 6 of 5 plus 18, which is equal to negative 12. So negative 12 is a value less than 0, a negative value. Means that the point x equal to 5 and the point is 5, 36 is a maximum point, because we have the value of d2y dx squared less than 0. Okay, so this is how we do in checking the nature by using the second derivative test. Okay, last for example 6. Given a curve y equal to 6x squared minus x cubed. Find the stationary points of the curve. So that is the first task. by using the second derivative test. Determine whether the stationary point are maximum or minimum. So the second question is to check the nature. As usual, we need to find the stationary point. We can differentiate the y to get the dy dx, to get dy dx equal to 0 lah. So dy dx is equal to 12x minus 3x squared. So after letting equal to 0, we will get 12x minus 3x squared equal to 0. So factorize out 3x. So we get 4 minus x inside the bracket equal to 0. Means that 3x equal to 0. 4 minus x also equal to 0. So we have x equal to 0 and x equal to 4. And then we need to find the y coordinate. So substitute the x equal to 0 and x equal to 4 into the function y back. So we get y equal to 0 for x equal to 0 and y equal to 32 when x equal to 4. So the two stationary points are 0, 0 and 4, 32. So now we have the stationary point already. This is the first task only. We need to solve for the second task, which is to find the nature. So to find the nature by using the second derivative test means that we have to differentiate the dy dx again. So differentiate dy dx, we will have 12 minus 6x. And then to check at a certain point x, let's say for x equal to 0, the d2y dx squared will be 12 minus 6 of 0, which is equal to 6. Sorry, it's not 6, huh? It should be 12 lah. Right? It should be 12. Because 12 minus 6 multiplied by 0, this is 0. So 12 minus 0 is equal to 12. So 12 is more than 0, means that the coordinate 0, 0 is minimum point. Yes, because it's more than 0. And then for x equal to 4, the d2y dx squared is 12 minus 6 of 4, which is negative 12. So negative 12 is a negative value, less than 0. Means that the point 432 is a maximum point. So we find out the nature of the point already. So that's all for this lecture. So by conclusion, we just need to find the stationary point and find the nature by using either the first derivative test or the second derivative test. That's all for today. Thank you everyone. So please continue with the tutorial questions.